For the newbies on this channel, my name is Olwale Godwin. Welcome to Economics. It's been a while here and I really like that we are having interaction with ourselves one more time. Now today we'll be talking about integration. We've discussed in recent time, in the past couple of weeks, we talked about matrices, we talked about calculus, we talked about quite a number of things. So in this particular video, we'll start talking about integration. But before I go into that, people that have been watching my videos, these videos generally, have been complaining. Some of them have been complaining that I talk too fast, and I'm really sorry for that. I've been trying to talk slowly, but it's just natural to talk pretty fast. So I'm going to try to continue to adjust. Okay, and on your part, I would like that you reduce the playback speed if you think I'm too fast for you. So there's a way to reduce the playback speed. So just hit your screen. You'll see an icon on the left corner, on the top left corner of your screen. Then when you click it, you see things like the video quality. Where you adjust your video quality, the playback speed. So click on the playback speed and reduce the speed. So the one that is convenient for you. And thank you very much. We've surpassed 1,500 subscribers, and that is so great. That's amazing. Thank you very much for sharing our videos. Thank you so much for recommending them to your friends and so on and so forth. Keep the good job up. Just keep it up. Please continue to share with your friends, share among your colleagues in school and so on and so forth, and help this channel to reach thousands and thousands, millions of students out there that have difficulty in understanding economics concepts. Thank you once again, and now let's get back to business. So what is integration? Integration is finding the original function from which a derivative was obtained. By the time if we are given, let's say we have f of x, right, equals x squared, then when we differentiate this, we have equals 2x. Now the process of turning 2x into x squared is what we call integration. Now the process of obtaining 2x from x squared is what we call differentiation. Alright, so integration is finding this original function from which this derivative was obtained, and it is also known as anti-differentiation, like against differentiation. I'm just trying to do the stuff all over again. Now we have rules of integration, and the rules are, I think I have 9 here, and some of them I just think they're not that necessary because they seem to be repetitions. But no problem, we are going to deal with them, in our own way. So number one, we have, when you have integral, we call this sign just like a slanted s kind of, integral of the x. Now, integral of the x, so you have something like this. So, how do we find the integration of this? Now, this simply means this is something as integral 1 dx, right? 1 times the x will give you the x back. Okay, trying to express this in terms of x is the same thing as integral x raised to power 0 dx. Of course, by now you should already know that anything raised to power 0 is equal to 1. Now, x raised to power 0 equals x raised to power 0 dx. So, integrating this is now, when we're doing differentiation, here, for example, this is 2x 2 minus 1, right? That is, the power here is 2, so you take 1 from the power after bringing the 2 here. Now we take 1 from the power of 2, and this gives us 2x raised to power 1, which is equal to tx, right? But by the time we are doing integration, what we do basically is to add. We add to the powers, we don't take from the powers, and then, so just look at me. So I have x 0 plus 1 divided by 0 plus 1, then plus c, which we call a constant term. Okay, that's a constant. So we have x squared, 0 plus 1 is 1, divided by 1, plus c, which is the same thing as x plus c. That's all. Now, why do we have a constant? So, how do we have a constant? Now, let me say this is not x squared, and it is x squared plus 5, for example, and there is another one that is kind of x squared minus 15. Okay, by the time we find, this is f of x, right? This is f of x, and that one as well. By the time we find the first derivative here, we have 2x, right? And by the time we find the first derivative here as well, we also have 2x. Now, integrating this, trying to integrate this, we won't be able to know what the constant was initially. So, is the constant 5? Is it 15? Is it 5? Is it minus 15? Whatever the constant might be. So we need additional information to be able to get what this is. So instead of bothering ourselves with that kind of problem, integration just assumes a plus c, right? A plus c. Now, why is it a plus c? Why not a minus c? Well, whatever the value of c is going to help itself out. Now, if c were 5, for example, if upon additional information we discover that c were 5, so that would be 2x, right, plus 5. And that will give us 2x plus 5 back, which is what we 2x, no, upon, sorry, we have 2x plus, okay, oh, 2x plus, okay, if we integrate this, so this is going to give us, we have, no, don't let me get to this, yet. Why we have constant as being a plus, let me get to that here. Let's just leave it this way, that we don't get to know what the constant is, alright, or what the constant of the original function was, so just say, okay, leave it as plus c, Now let me continue, because trying to go further there would mean that you need to have understood something that I am going to explain here, which I have not explained yet. Now the second rule says when you have integral k dx, k being a constant term, alright, so it's the same thing as saying k here, bring the k outside, integral dx. Now where is this necessary? Where is it useful? Let's say we have a function that says integral 5 5x, so we can just say this is 5 integral x, alright, x dx, right, 5 integral x dx. Now we can continue with this obviously, so which is going to give us 5, then this is x raised to power 1 already, right, x raised to power 1 is x raised to power 1, then we add the plus 1 divided by 1 plus 1, right, plus the constant term, alright, and this gives us 5 into bracket x squared over 2, then plus c, and by the time we finish the whole thing, we have 5 over 2 x squared, right, plus c, or some people decide to write things as 5x squared, over 2, then plus c. Whatever way you decide to write it, that's the answer. Now the thing is that we could actually continue from here instead of bringing out the constant term, and then so that was going to be like integral 5, this is x to the power 1 dx basically, so that will give us, integrating this will give us, the 5 is still there, x raised to the power 1 plus 1 divided by 1 plus 1, then plus c, and this gives us 5x squared divided by 2 plus c. But then rules are rules, so it's not bad if you know that. Now let's go to the third rule. Now I need to rub off the stuff that I've written here. Okay, so we have rule 3. So what does rule 3 say? Rule 3 says that if you have integral x of n dx, so what's that going to give us? So by the time we integrate this, we'll be having x raised to the power n plus 1 divided by n plus 1 plus c. Actually, that is what we've been doing here basically, because let's assume this way. Let's assume in this question, for example. Okay, let me just write another question here. So we have integral, let's say x raised to the power 7, x raised to the power 7 dx. So this is saying that we'll be having x raised to the power 7 plus 1 divided by 7 plus 1 and plus c. And by extension, we have x raised to the power 8 over 8 plus c. That's all. Alright. So, very simple, right? Yeah, very simple. Integration is very simple. You are wondering, so why is this kind of a thing taught in a university or a college if it is that simple? Well, I don't know. Now you have x minus 1. If you have, basically x minus 1 is same as 1 over x, right? Okay, same as from the law of indices. Now let's say we have integral, let's say we have integral x minus 1 dx, which is question 4. Alright, which is same thing as saying that we have integral 1 over x dx. So whenever you have something like this, 1 over x or x to the power minus 1 becomes ln x. That is the rule. Yeah, I didn't make the rules basically. So that is the rule. So this is going to be integration of 1 over x will give us ln x, then plus the constant term. So that's it. So let's say let's give an example. So we have integral 1 over, let's say 5x plus 2, right? 5x plus 2, then dx. Alright, so what this is trying to tell us that we have, this is going to be integral 1 over 5x plus 2. Alright, so this is 1 over a function of x, right? So I don't need to write integral anyway. I don't need to write integral again. So this is just going to give us ln 5x plus 2, then plus the constant term. That's all. So we are done with that. Now question 5. I think I need to change this marker. Okay. For rule 5 rather, not question 5. For rule 5, we have what do we do when we have something like this? Integral a k raised by x dx. What do we do when we have something like this? Now this is going to be whenever you have a raised by k, whatever, is going to be the whole a raised by kx, a raised by kx, now divided by, k is actually a number that is, beside x. Alright, so we write this k, whatever number is here, we write it out first, k, then we say ln a, alright, and everything plus the constant term. That is the rule, right? I didn't make the rules like I said earlier. Now I think I have a question on that. So an example of this is integral 2 raised by 3x dx, right? So this is just going to give us, we'll write the whole thing back, 2 raised by 3x divided by 3 ln 2 plus the constant term. Simple. Alright. Now number 6. Rule 6 is saying, what if we have integral e, right, this exponential, e raised by kx dx. Now this is I think this is the sweetest thing I know in integration. It's so sweet simply because there's no problem at all. It's going to give us e raised by kx again by the time we integrate it, then divided by whatever is beside x, k. So instead of having 3 ln whatever here, because it's an exponential, this is e, so it's going to be over the k, over whatever is beside x, which is k, then plus c. Very nice. Now to save up space, so let me give an example. So we have integral, where is this guy? Trying to look for this guy. Okay, or if I don't get him, then I'll just have to formulate a question on my own. Okay, let's say we have something a little bit, so we have integral 6 e raised by 3, no, don't let me get here first, So let's say we have integral e raised by minus 8x, for example. Alright, so this is just going to give us e raised by minus 8x again, divided by what is beside x, minus 8, then plus the constant term. So this is basically minus e raised by minus 8 over 8, then plus the constant term. So nice, right? So nice. No trouble for anybody. Now number 7, which is rule 7. So we come back to what's rule 7. So what if we have integral k and a function of x? Now k being a constant term, then dx. K being a constant term, then dx. So this is just going to give us, we take the k out. I think did we mention something like that earlier? Which is, is basically what we have here. We take the k out, then k integral whatever is inside. Just like in this case, we didn't have an x function inside, we had just one. But here we're having an x function. Okay, this is what I mean. So this gives us k integral whatever the function of x is, function of x, then the x. Yeah. Now to give an example to talk about and illustrate what I mean here. Let's say we have integral. Let's see if I have a question here. 5x raised by 4. So it won't look like I'm just pretty much using easy examples. Okay, 5x raised by 4, for example. Now this is 5 being the constant, and this is a function of x, which is x raised by 4. It can be longer than that basically. So this is saying that we'll have 5 outside, integral x raised by 4, okay, dx. Yeah, so that's it. So this gives us we have 5. Then by the time we integrate what is there, so we have x raised by 4 plus 1, right? Divided by 4 plus 1, then everything plus the constant term. Right, so we have that gives us 5 x raised by 5 divided by 5, right? Then plus the constant term. So this takes this. Yeah, right? Then at the end of the day, we have x raised by 5 plus the constant term. So that's it. So by the time we've integrated this, so by the time we differentiate this, trying to get what was here back, that constant is going to be useful. Alright. Now for rule 8, so let me just drop off the board a little bit. All of these things, they are pretty, they are simple things. I think let me rub off this. We may not be needing this that much anymore. Integration is just so sweet, but as an economics student, please don't assume that the kind of integration that you know is similar to the ones that they know or they do in engineering mathematics classes, in engineering classes or mathematics classes. Please and please, they are not the same. Economics, mathematics is one of the tools of economics. So economics just takes the aspect of mathematics that it needs, to simplify whatever it is trying to talk about, or to work out whatever it is trying to illustrate or talk about. So it may not be the entire thing. By the time you open some calculus books, these things are just tiny bits of what you are going to have at the end of the day. But that's not a problem. That's their own problem. So rule 8. If you have integral a function of x like this, a function of x, then plus g, another function dx. Okay, these are two functions basically. So you can just write them as integral f of x, okay, dx, plus integral g of x dx. That's all. So by the time we do the integration, of course we are meant to be having a constant term from this guy, and I'm meant to be having a constant term from this guy, but we just write a single constant term, so we don't have to put ourselves in unnecessary, Now, an example to show what I mean here is you have integral 3x cube, okay, minus x, then plus 1 dx. So this is basically integral 3x dx. Okay, this is a minus, right? Minus integral x dx, then plus 1 dx basically. So here we are having 3. Okay, let's try solve the whole thing. By the time we solve this guy out, we're having 3x raised to power 3 plus 1 divided by 3 plus 1 minus this guy. This is just x, so x raised to power 1, right, plus 1 divided by 1 plus 1. Then this is just 1, which we can express in terms of x to be x raised to power 0, right? So I have x raised to power 0 plus 1 over 0 plus 1, then plus a single constant term, and we are okay. So this is going to be 3 over 4 x raised to power 4 minus 1 over 2 x raised to power 2, right? Then plus, this is x, just x, then plus c. So that's it. So we are done. Now, the ninth row says whenever you have integral minus f of x dx, alright, minus f of x dx, okay, that's going to give us what we already know anyway. So the minus be outside, and integral f of x dx. So this thing just makes us kind of question our intelligence. That's we are just trying to say the same thing at different times, because what is meant here essentially, this is like a minus 1, right? This is like saying you have integral minus 1 then f of x dx. Now basically from one of the rules, right? So this is a constant term, and minus 1 is like k, just like the k, right? And you bring the k outside, so you have minus 1 integral f of x dx. So what's the difference? Where is that rule? Yeah, it's just what is there. But here you have a positive k, and you have a positive number for k, which is 5, and here you have a negative number for k, which is, so why make it a different rule? Anyway, that's about that. Now is there a question? Do I need to write a question? Okay, let's just have we have let's say, let me bring a question from my small head. So you have minus the entire function of x cubed plus x raised to power, let me say half, yeah, to make things a little bit interesting. Okay, then dx. So let's say we have something like this. Now this is just going to give us minus integral x raised to power 3 plus x raised to power half. Yeah, this is nice. The x is still there. The x is still there. Okay, cool. Now when we integrate that, so we have a minus outside. When we integrate that, we have x raised to power minus, close the bracket because it's meant to be in the bracket, 3 plus 1 divided by 3 plus 1, right? Then plus x raised to power half plus 1 divided by half plus 1. Then just plus c outside. It's okay that way. Now this is going to give us x raised to power 4 divided by 4. Then plus half plus 1 is 1 and a half, right? And 1 and a half is 3 over 2, basically. Okay, well, there might be people that have difficulty with mathematics. Half plus one, okay, you got half of a thing, then you are getting one of the thing, the same thing again. So you have 1.5 of that stuff. Well, let me just do the fractions. So you have 2 here. 2 into 2 is 1 times this 1 plus 1 into 2 is 2 times 1 is 2. Then we have 3 over 2. Right? That's I'm a teacher, so I get to understand that there are students that have issues with even the most basic things in mathematics or arithmetics, and because of them, let's just do that. So you don't assume that everybody knows all of these things. So this is x raised to the power 3 over 2. Now divided by 3 over 2 actually, alright, plus c. Now let me just because of space, so this is 1 over 4 x raised to the power 4, okay, plus x raised to the power 3 over 2. Now this is divided, so just trying to make this easier, divided by 3 over 2. Now in subsequent solutions, I will not do something like this anymore. If I just want to do it, I'm not doing it now, so I will try to understand what is going to happen, but it doesn't look like magic. Right, so from there we'll be having, this is divided, right? And we're having 1 over 4 x raised to the power 4 plus x raised to the power 3 over 2, then times 2 over 3, right? So all of this plus c, and then it then gives us, we still have 1 over 4 x raised to the power 4, right? Then this is going to become 2 over 3 plus 2 over 3 x raised to the power 3 over 2, x raised to the power 3 over 2, alright, then plus the constant that is outside plus that constant. So that's it. So we are done. That's how to find that's how to find the integration of, that's how to integrate this kind of function, and then we get this. Now the funny thing is, hope I've not omitted something, because there is a negative here, and the negative is still here. The sign came here. There is the negative here as well, right? There's a negative here, so the minus is still here. I know some people must have been wondering, where did that minus go? Sorry, I skipped it. Yeah, I skipped it. So you have minus here, and the minus is still here. Okay, let me just make this, let me just say plus c here. So so this is, the minus is still here, right? The minus is still here as well, because we've not opened the brackets. And then here that we've opened, okay, here that we've opened the bracket, so we're having minus times this is going to give us minus. Let me just make this smaller. C, so we just say, so just give space. So we have minus, because minus times this is minus, then minus times this plus as well is also minus. So this guy is actually a minus here. Alright, so we have, then leave C the way it is, okay, just plus C, that's fine. Now I think I was trying to explain something the other time about this. Why is the constant a plus? Why is the constant not a minus? And I was saying, okay, let's give an example. Here for example, we add, I'm trying to look for something that's not going to be difficult for us to solve again. So here we had x raised to the power 5 plus c. Was there a constant? Okay, I don't want to use lane. I think I should illustrate that point. Okay, so let's say I'm going to give an assignment anyway. So, and I want you guys to really do the assignment. Do the assignment and leave your answers in the comments section. So that would really show if you understand what we are saying and if you're actually following. Alright, I would really appreciate that, as usual, I would really appreciate that. So let's say we are integrating, let's say we have 5x cubed, 5x, no, let me make this 5x to the power 4, then plus 13. Okay, let's say we have something like this, plus 13. Okay, now by the time we integrate this is going to give us, don't let me go through the stress of taking one guy out or something like that. We have 5x raised to the power 5 divided by 5 plus 13x plus 13x, alright, then plus the constant term. Now this cancels this, so we have x raised to the power 5 plus 13x plus c. Now let me try to differentiate this. By the time we differentiate this, we'll be having differentiation is saying, so we have, this is f prime, So this is the new function that we have. We've integrated this guy to get this guy. So we want to, wait, what am I saying? We've integrated this person to get this person. So we want to differentiate and see if we get this guy back. No, that's not what I meant to say. That's what I meant to say. The first step is to differentiate something, right? And then the next step is to integrate. Alright. Okay, so now let's say we have this guy first. Let's say we have x raised to the power 5 plus 13x. X raised to the power 5 plus 13x. So let me do something. So we have f of x as x raised to the power 5 plus let me say 12. Yeah, plus 12. So this is it. So we differentiate this guy. By the time we differentiate this guy, we have, well, let me make this a minus 12, for example. Minus 12. By the time we differentiate this guy, it becomes a 5x raised to the power 4. Right, and the minus 12 disappears. Right. That was the point I was trying to get the other time. Now the minus 12 disappears, right? When it does that, so we want to integrate this and see if we can get this function back. Right, so we are doing integration of 5x raised to the power 4 dx. Right, so this is going to give us, of course, this is now, we say we take this guy, so don't let us break the rules again. So 5 then x raised to the power 4 dx, and this is the same thing as 5 into bracket x raised to the power 4 plus 1 divided by 4 plus 1, then plus the constant term, right? Now we have 5 into bracket x raised to the power 5 over 5, then plus the constant term, and this cancels this, so we have x raised to the power 5 plus c. You see that without an additional information, we can't get what the constant of the initial function was. You understand? So that is why there's a plus c. That's why there's a plus c there. And in this particular function, in the original function, it was a minus, so we don't get to know, is it plus, is it minus? Now, what is it supposed to be? Why do we put plus constant every now and then instead of minus the constant? Now, let's say we got to know that the constants were minus 12, right? So we have x raised to the power 5 plus minus 12, and this is going to give us x raised to the power 5 minus 12 back. Simple, right? So that's how it goes. So whatever the final function is going to be, the constant term, the value of the constant term determines it. Alright, because minus times plus will give you what it was here before. And imagine that the constants were just 12 initially. So that would have been x raised to the power 5 plus plus 12. I would have had the function that would be x raised to the power 5 plus 12, and that will be it. Alright, so that's imagining that it's a plus. Now let's say that the constant here were minus. So we have, that would have been x raised to the power 5 minus c. So let's say instead of having x raised to the power 5 plus c, we have x raised to the power 5 minus c. And we got to realize that the constant term c is actually minus 12. Because let's say we got to have a still into what initially happened, that c here was minus 12. Now trying to bring c back into this place will be x raised to the power 5 minus 12. And this will be x raised to the power 5 plus 12. So it changes the whole thing, right? It was minus here and it's already a plus here. So it changes the whole thing. That's why we have plus the constant term whenever we are doing integration and so on and so forth. Now let me write your assignment. Let me write your assignments. So let me put it here. So you're going to find, you are going to do the integral of 1 or 2 questions for me. There are not many. I've done most of them on the board. So you have your assignments. So please, I would like to have your answers in the comment section. So you have your assignments. So question number 1 is okay. Just find the integral of the following. That's the instruction. So you have integral dx over x. Ah, nice question. Now number 2, you have integral. You have integral 6e raised to the power 3x minus 8e raised to the power minus 2x, then the x. Alright, and question 3, now I won't bombard you with too many questions. Question 3, you have integral, I don't know if I have done this before, 5x cubed plus 2x raised to the power minus 2 minus 3x raised to the power 4, and the x. Yeah. So is there anyone that looks like a tough one again? Now number 4, you have find the integral of 2 raised to the power 4x dx. And then the 5th one, which is actually a pretty nice question, integral 2x raised to the power 5 minus 3x raised to the power minus 1 over 4. Okay, the x. Even if you don't do any question, like you just Number 5, just try to lay your hands on it and leave your answer in the comment section. Alright, so that's about this particular video. Once again, I thank you very much for sharing this video and making us to have the number of subscribers we have now. I don't know when someone else will be seeing this video, probably that time to be 1.5 million subscribers. But right now it is 1,500 subscribers, and we really appreciate you guys for the work you do. Please ensure that you watch these videos online. I don't mind if you download the videos, so I don't mind at all. We don't mind at all, because there are times you have to attend these classes over and over again. But please, for the sake of our profitability, please make sure that you watch online at least. Please and please don't watch for 1 minute, watch all through online, then you can go on and watch whenever you've downloaded, if you really feel like downloading. Alright, you can just save to watch later instead of downloading and then watching online. It helps us. If you want more of our classes online, please watch online. Please. Thank you very much, and see you in the next video, where we shall be talking about integration by substitution. Thank you.